Okay, class, we're about to start example 2, the sample test. Okay, now, it says simplify each expression by hand, assume all variables are positive. So, we would take 4 times negative 3, which would give us negative 12. B to the third times B to the 7th. We know that's the same as saying B to the 3 plus 7. So that'll give us negative 12 B to the 10th. And that would be our final answer. The negative 12 B to the 10th. Now, we go here to B. This parenthesis is squared. So that means everything in this parenthesis is taken to the second power, even the negative sign. Whenever you have an even exponent on the outside, and it's a negative on the inside of the parenthesis, your answer is going to be positive. So we could just take 5 squared, which would be 25. C to the 4th to the 2nd, we know that's the same as saying C to the 4 times 2 power. So it would be 25 C to the 8th. Okay, now, we go here to C. We have 6m to the 10th over 24m to the 6th. Now, if we look here at 6 and 24, we know both of these have 6 in common. So we could divide both of these by 6. Then our denominator will have 4, our numerator will have 1. Now, m to the 10th over m to the 6th. Now, we know this would give us m to the 10 minus 6. So this would give us 1m to the 4th all over 4, which is just m to the 4th divided by 4. Now, of course, on your exam, you don't have to show all of these extra steps, but I'm showing all of these extra steps for those of you that may need a refresher on how we did this previously. Okay, now we go to D. We have d to the negative 6 over d to the 3rd. Now, we know since this is d to the negative 6, we know that that goes to the denominator, and it goes down there positive. And then there's nothing left in the numerator except 1. So this would give us 1 over d to the 9th power. Are there any questions? No questions. All right. Now we go to the next problem here. Now, of course, you know on your sheet, these numbers are exponents, but when I converted it, it looks like these numbers are in a regular place here. So this is really x to the 5th, y to the negative 3rd, over x to the 8th, y to the negative 4. So now, we have the same base. We subtract the exponent. So it'd be x to the 5 minus 8, y to the negative 3 minus a negative 4. So this would give us x to the negative 3, y, this would be negative 3 plus 4, which would be 1. Now we know x to the negative 3 will go in our denominator as x to the 3rd. Our numerator would just be y or y to the 1st. So it would be y over x to the 3rd power. Now we go here to F. If you notice here, this second parenthesis is taken to the second power. So let's take care of this first parenthesis first. Since we have c to the negative 8, we know that our numerator would be 7d squared, and our denominator would be c to the 8th. Now in this parenthesis, we would have 3 times d over c squared, and that parenthesis is still squared. So we have 7d squared over c to the 8th, and that'll be multiplied by 9d squared over c to the 4th. Now we multiply straight across. 7 times 9 is 63. D squared times d squared is d to the 4th. C to the 8th times c to the 4th is c to the 12th. And that is our final answer. Now we go down here to G. G, we have 64, a to the 6, b to the 12/5, all taken to the 5/6 power. So now what I would suggest before we do anything, let's take all of these to the 5/6 power. We know that 64 is really to the first power. So it'll be 64 to the 5/6 power. So this would be A. So we'll take 6 times 5/6, which will give us 30/6. And then B, we'll take 12/5 times 5/6, which will give us 60/30. So now, 64 to the 5/6 power. This is really, we could take our calculator and we could take 64 and we would take it to the 5/6 power. And that would give us 32. So this would be 32. 30 divided by 6 is 5. This would be a to the 5th. And 60 divided by 30 is 2. So that would be b squared. So this would be our final answer. It would be 32, a to the 5th, b to the 2nd. Now we come here. Now you notice this is a little jumbled, but on your paper you notice that all of the numbers and the values are here. So what we could do is this. Let's take everything to the -4th power inside the parenthesis. This will give us b to the 12/2 power all over a to the -1 power. Because we know 1/4 times -4 is -4/4, which is -1. So this will give us b to the 6th all over a to the -1. But since we know that this exponent is in the denominator and is negative, we know we would bring it up top. And this would give us a times b to the 6th. And we don't have to write the denominator of 1. So that is our final answer. Now we look here, down here at number 2. It says write the number in scientific notation. Now we know that we need to move this decimal 1, 2, 3, 4, 5 places. So it'll be 5.75, because remember, in front of the decimal, it must be a number that's not 0. So we have 5.75 times 10, and we move this decimal 5 places to the right, so it'll be to the -5 power. Now, for number 3, it says write the number in standard notation. Now we know that this E really means 10, well, times 10, and this 4 would be the 4th power. So this is really -4.185 times 10 to the 4th power. So this would mean that we would move this decimal 4 places to the right, so it would be -41,850. Any questions on the first page? Okay, now we go to the second page. It's the same thing. It looks a little jumbled here, but it's still a -3/2. So it says for f of x, 4 to the x, find f of a -3/2 by hand. So what we would do is we would substitute in a -3/2 for x. So what will happen here is, since this is negative, we know this will become 1/4 to the 3/2 power. So now we need to rewrite this. This will become 1 over the square root of 4, or the cube root of, no, it's the square root of 4. It'll be the square root of 4, and then that answer would be taken to the 3rd power. So this will give us 1/2 to the 3rd power, which is 1/8. Are there any questions on this problem? Because remember, this denominator, this is going to go inside of the index of the radical. And since it's a 2, we would just do the square root. If it would have been a 3, we would have put a 3 there. Does everyone follow that? All right. Now we go here to number 5. We have graph the function f of x equals -5 times 2 to the x by hand. Include any point that fits on the grid carefully drawn. State the domain and range. Now we know, first of all, we know that the y-intercept would be 0, -5. So we would go here on the graph at 0, -5. We know that that is our y-intercept. Now sometimes this would disappear whenever I put it on the graph here. So now we could actually do a little table here. We could put some other points here for our x and y. Let's just say we made x, well, first of all, we know it's 0, then -5. If we made x 1, then it'd be 1, -10. If we made it, let's see, let's try 2. If we made it 2, it'd be -20. And then 3, we know that would give us a -40. You know, as we increase by 1, you notice that we're multiplying by 2. So let's plot those points. We have 1, -10. We had 2, -20. Then we had 3, -40. And you notice here this 2, -20 disappeared and 3, -40 did too. So now we have a graph here. Now we can do the -1. If we go back with the -1, we would have to divide this by 2. So it'll be -1, and then it'll be a -5/2, which we know would be a -2.5. So we'll go -1 and -2.5 would be about here. Then we could go. Now, of course, your drawing would be a lot better looking than mine. But remember, it never touches the x-axis. So now, this is basically the graph of this here. They want the domain, which is the x values. There's no restriction on the x values. So your domain would be -infinity to infinity, because x can be anything. It's the y that has a restriction on it. If you notice, y would never be positive because this graph would never touch or go across the x-axis. So we know y would never be positive, so it would be -infinity to 0, and 0 is not included. So that would be the range. Does everyone follow that? All right, now we scroll to problem 6. It says some values of function f and g are provided in the table below. Determine whether each function is exponential, linear, or neither. Okay, first of all, we look here. We notice that x is going up by 1. If you notice here, by every 1, we're dividing this by 2. So we know that this has to be exponential. Now, if you look here at g of x, if you notice, we're subtracting everything by 40. So that would have to be linear. Now here, we're multiplying by 3. Everything is multiplied by 3, so that's exponential as well. So if it's not consistently multiplied, added, or subtracted by something, then that lets you know that it'll be neither. Does everyone follow that? Now it says here, if f or g or h is exponential or linear, find a possible equation for it by hand. Now the linear would be quite easy to do because all we have to do is find the y-intercept, which would be 4, and we already know the slope. So y equals mx plus b. We know it's going down by 40. So we know our slope would be -40, and our b would be, wait a minute, our b, oh, we don't, okay. We don't, it's not listed what our b is, but we can find it. Because our b is when x is 0. Since we know that it subtracts 40 as we go down, when we go up, we would have to add 40, right? So then that would be, our b would be 160. So it would be y equals -40 x plus 60. That would be your formula for the linear.